Hello students, Sacred Heart High School welcomes you. Today we are going to study Chapter 6 of Standard 8, Composition of Matter. Matter. In previous standards, we have studied that all the objects in our surrounding is made up of matter. Matter is anything that occupies space and has mass. All physical objects are composed of matter. We have also studied that matter exists in three states: solid, liquid, and gas. States of matter. Let's study this by doing an activity. Take some mustard seeds in a transparent plastic jar. Take a long thread and tie it at the center of a big balloon by means of a needle. Stretch this rubber diaphragm and fix it on the mouth of the jar by means of a rubber band. Pull the diaphragm up and down with the help of the thread. Do it slowly at first, then with moderate force, and then vigorously. In this experiment, by pulling the thread, the rubber diaphragm moves up and down, giving energy to the mustard seeds, and they also move up and down. The particles in the solid, liquid, and gaseous states of matter have movement somewhat similar to the mustard seeds. Let us study the different physical states of matter. Intermolecular force of attraction acts between the particles of matter. Intermolecular force of attraction is the force that occurs between two molecules. How the particles move depends on the strength of this force. Solid. The particles of solid are very close to each other and they vibrate at their fixed position. Hence, solids have definite shape and volume. They also have high density, that is, degree of compactness, and non-compressibility. Means you cannot squeeze solid as the particles of solids are very tightly packed. The strength of intermolecular force is very strong in solids. Liquid. The strength of intermolecular force is moderate in liquids. It is not very strong enough to fix or place the particles in one position, but it is strong enough to hold them together. As a result, liquids have definite volume. They have fluidity, means they flow, and their shape is not definite, but it changes in accordance with the container. Gas. The intermolecular force is very weak in gases. Therefore, the particles move freely and occupy all the spaces. They don't have proper shape nor proper volume. Elements. It is a substance which is made of only one type of atom. Elements are simplest substance and hence cannot be broken down. They are composed of atoms that have same atomic number, means it also has same number of protons in their nucleus. Example, hydrogen, oxygen, nitrogen, gold, etc. The smallest particles of an element contains identical atoms. Example, each molecule of oxygen contains two oxygen atoms in a bonded state. All the atoms in a molecule of an element are alike and are joined to each other by chemical bonds. Compounds. Compound is formed by joining two or more different types of atoms to each other. Example, each molecule of water contains two hydrogen atoms joined to one atom of oxygen. Constituent substance of a compound is only one, and it is that compound itself. The proportion of constituent elements in a compound is constant. Properties of compound are different than those of the constituent elements. Example, hydrogen is an inflammable gas while oxygen gas supports combustion. However, the compound water formed by chemical combination of the gaseous elements hydrogen and oxygen is a liquid. It is neither inflammable nor does it support combustion. Mixtures. The smallest particle of mixture are atoms or molecules of two or more elements or compounds. The constituent molecules of mixtures are different from each other and they are not joined by chemical bonds. The properties of constituent substance are retained in the mixture. Example, carbon dioxide, H2O, etc. Types of elements. Elements have different physical properties like luster, paleness, malleability, brittleness. According to that, elements are classified. In early times, elements were classified into metals and non-metals. After invention of new elements, a new type, metalloid, is discovered. We are going to study about this in chapter 7. Types of compound. Let us study types of compounds by doing an activity or an experiment. You need evaporating dish, tripod stand, burner. You also need chemicals like camphor, washing soda, blue vitriol, sugar, glucose and urea. Keep the evaporating dish on the tripod stand. Take some camphor in the evaporating dish. Heat the camphor in the dish strongly with the help of a burner. Find out what remains behind in the evaporating dish. Repeat the above procedure using limestone, washing soda, blue vitriol, sugar, glucose and urea instead of camphor. Record your observations. Now we will see what happens after this process is done. Organic, inorganic and complex compounds. In the above activity, we saw that some compounds leave a residue behind after burning. Some compounds do not give any residue, or some compounds give blackish residue. Residue means a substance that remains after a particular process is done. The black residue that remains is mainly made up of carbon. When such compounds are strongly heated in air, they combine with oxygen to form some gaseous substances. In case their combustion is not complete, black colored carbon remain behind as a residue. These compounds are called organic compounds or carbon compounds. Organic compounds are those compounds where one or more carbon atoms are linked with atoms of other elements. For example, materials like carbohydrates, proteins, hydrocarbons are made of organic compounds. Camphor, sugar, glucose and urea are also organic compounds. Inorganic compounds. Some compounds decompose on strong heating and leave a residue. These compounds are called inorganic compounds. Inorganic compounds do not have carbon in them. Complex compounds. There is one more type of compounds, complex compounds, which is made up of two compounds or more than two compounds. Its structure is said to be complex because it is formed by many atoms and in the center a metal atom is also present. Examples: chlorophyll that contains magnesium, cyanocobalamin that is vitamin B12 that contains cobalt are some examples of complex compounds. Types of mixtures. Let's study this by doing an activity. Take 3 beakers. Take a little sand and water in the first beaker. Take some crystals of blue vitriol and water in the second beaker. Stir the materials in all the beakers and observe. After observation, you will see that sand and water in the first beaker do not mix with each other, whereas blue vitriol and water in the second beaker mix with each other completely as blue vitriol dissolves in water. Now what have you understood from this? Let's see. The part of matter having a uniform or same composition is called phase. When all the components of mixture form one phase, it is called homogeneous mixture. It has same proportions of its components. Example, blue vitriol and water. Blue vitriol easily and completely dissolves in water and it forms one phase. Another example is sugar and water, also salt and water. When the components of mixture are distributed in two or more phases, it is called a heterogeneous mixture. Example, sand and water. Sand does not dissolve in water and it forms two phases. Another example is oil and water. Let us study three distinct types of mixtures. Before that, let's do an experiment. Take 3 beakers, take 10 grams of common salt in the first beaker, 10 grams of sawdust in the second beaker and 10 ml milk in the third beaker. Add 100 ml water to all the 3 beakers and stir. Place the 3 beakers in front of a vertically held paper and pass a laser beam through the beakers from the opposite sides. At the same time, observe what appears on the paper in front of the beaker. Also, look at the beaker from the side. Arrange 3 filtration papers using a conical flask funnel for doing filtration. Stir the mixtures in the 3 beakers and carry out filtration. Record all the observations. Let's see first mixture. Solution. Solution is a homogeneous mixture of 2 or more substances. In the first beaker, a homogeneous mixture of salt and water is formed, which is called a salt solution. A solution consists of solute and solvent. In a solution, solvent is present in the largest proportion, example water, while solute is present in smaller proportion, example salt or sugar. The solute is mixed in solvent which forms a solution. This process is called dissolution. Solution can be of many types. The solutions such as seawater, blue vitriol, dissolved in water, salt dissolved in water, sugar syrup are of the types solid in liquid. In addition to this, the solution can also be of the types liquid in liquid, example vinegar, gas in gas, example air, solid in solid, example alloys like brass, and gas in liquid, example chlorinated water, cold drink, etc. The composition of a homogeneous mixture, that is to say solution, is uniform throughout the bulk. If solvent is a transparent liquid, the solution is also transparent and it passes through a filter paper. Suspension. In the second beaker, a heterogeneous mixture of water and sawdust is formed, as sawdust does not dissolve in water. It is a mixture of liquid and solid. A suspension is a heterogeneous mixture in which solid particles do not dissolve but get suspended, means the particles are left floating freely in the medium. The diameter of solid particles in suspension is larger than 10 raised to minus 4 meters. Therefore, the light cannot transmit through it. When filtration is done, the solid particles of sawdust remain on the filter paper as residue and the liquid and solid components of suspension gets separated. Colloids. In the third beaker, the translucent mixture of water and milk is formed. It means that when light is incident on the surface of this mixture, it is partly transmitted and partly scattered. This is because the tiny particles of milk are spread evenly in water and their diameter is 10 raised to minus 5 meters. The laser beam is incident on these particles and it gets scattered. The laser beam, which is not incident on any milk particles, gets transmitted. Such heterogeneous mixture is called colloid. The pores of ordinary filter paper are larger than colloid and hence this heterogeneous mixture cannot be separated. Apart from this, there are some more types of colloids such as solid in gas, example smoke, liquid in gas, example fog, cloud, etc. Let us understand compounds. Compounds and mixtures are formed from two or more units. Whether these units are in joint state with each other or separate decides whether the matter is a compound or mixture. Let's do an experiment. Take two evaporating dishes. Take 7 grams of iron filings in the first dish and 4 grams of sulfur in the second. Take a horseshoe magnet near the matter in both the dishes and observe by taking the horseshoe magnet near the matter. Also, observe the color of the matter. Now, heat the matter in the second dish for a while and let it cool. Observe the color change and also observe whether there is any effect of horseshoe magnet on it. In the above activity, when the magnet was taken near the first dish containing iron, the iron filings got attracted to the magnet. The sulfur didn't get attracted to the magnet. On testing the matter obtained by mixing iron filings and sulfur with the horseshoe magnet, it was found that the resulting matter was a mixture of iron and sulfur. The mixture had properties of both iron and sulfur respectively. In the mixture, some particles were in yellow color, that is, it was sulfur, and some particles were in black color, which was iron filings. When a magnet was taken near the mixture, the iron particles got attracted to the magnet, means the property of iron particles to get attracted towards the magnet was unchanged. When the mixture of iron and sulfur was heated and cooled, there was no effect of magnet on it and the characteristic yellow color of sulfur had disappeared. From this, we come to know that the matter formed by heating the mixture of iron and sulfur is different from the original components. A chemical combination took place between iron and sulfur due to heating. The atom of iron and sulfur became joined by chemical bond to form molecules of a new compound. A chemical bond is an attraction between atoms or molecules that helps the formation of chemical compounds. Molecular formula. In any compound, a definite proportion of the element is present. A molecule of compound is formed by joining a certain number of atoms of constituent elements to each other. Example, water. The molecular formula of water is H2O. Its constituent elements are hydrogen and oxygen, and number of atoms of constituent elements are 2 hydrogen and 1 oxygen. Molecular formula indicates the number of atoms of each of the constituent elements present in one molecule of the compound. A molecular formula includes the information regarding the symbols of the constituent elements and their respective numbers as subscripts. Valency. The ability of joining to another atom with a chemical bond is the chemical property of an atom. This ability is indicated by valency of atom. Valencies of constituent elements can be deduced or determined from the known molecular formula of a compound. Example, hydrochloric acid. The molecular formula of hydrochloric acid is HCl. Its constituent elements are hydrogen and chlorine. Valency of hydrogen is 1. Number of bonds formed by chlorine with hydrogen is 1. Therefore, valency of chlorine is 1. Second example, ammonia. Molecular formula of ammonia is NH3. Its constituent elements are hydrogen and nitrogen. Valency of hydrogen is 1. Number of bonds formed by hydrogen with nitrogen is 3. Therefore, valency of nitrogen is 3. Cross multiplication method for writing the molecular formula of simple compounds. Step 1. Write symbols and valency of constituent elements. Here we have taken carbon and oxygen. The valency of carbon is 4 and valency of oxygen is 2. Step 2. Cross multiply to obtain the number of atoms of the constituent elements in the molecule of the compound. You can see the cross multiplication on the screen. Step 3. Write the molecular formula obtained by cross multiplication, that is C2O4. Step 4. The number of constituent atoms in the molecular formula should be the smallest possible whole number. So divide the formula which is obtained in step 3 by a suitable number. Divide C2O4 by 2. Final molecular formula is CO2, which is carbon dioxide. Second example. In this we have taken the elements carbon and hydrogen and their valencies are 4 and 1 respectively. Cross multiply them. The molecular formula that you will obtain after cross multiplication is CH4. Divide the formula by 1. The final molecular formula will be CH4, which is methane. I hope you have understood this lesson. Thank you.